Okay, so far we've looked at 4 different constraints. They're all listed here. They're all listed here in the order that I asked you to view the videotapes. Constraint 1, I can reconstruct it from the video that you've already seen. It goes through the points 0, 6, 10, 0. So if I were to plot it, not very well, apparently I'm plotting it, that's what that would be. And we found out that the feasible region for it is the area below the line. Constraint 2, I'll use blue. Constraint 2 is 3x plus, or actually, let me say that this is constraint 1. Now constraint 2 is, we plotted it, and it goes through the origin. So it goes through the point 0, 0. And then the other point that we found was 1, 4. So here is 1, 4. So if I were to connect those 2 points and then extend it, that would be the constraint for that. That would be the line for that constraint. And this is constraint 2. And we found that the area below the line, so over here, is the feasible region for it. Now I'm not going to draw all of this area or highlight it because in linear programming we want all of the constraints to be satisfied. So one by one we find the feasible region and we see what's that overlapping feasible region. So far for these 2 constraints, this is the feasible region. Then the third constraint was, and I will use a different color, I'll use red, was x less than or equal to 5, was this one. So here was that constraint right there. This is constraint 3, and we found out that it's the area to the left. So far, this is the feasible region for all of these constraints. And constraint, and I will use purple. Constraint 4 was y less than or equal to 4. Actually, let me use this color. So that was this one right here, and this is constraint 4, and we found out that the feasible region for it is the area below. So it's all of this area. That is the feasible region for that constraint. So the overlapped constraints, or the feasible region for them, go from this point to this point to this point to this and to this. I'm going to label these using, actually let me highlight them, or I'll use this fuchsia color just to make them visible. And then I'm going to label them with the letters A, B, C, D, and E. So our corner points for our feasible region for this entire problem set are A, B, C, D, E, those points, because they contain the overlapped feasible region of all the constraints. And now if I go to my objective function and plug each of these points in there, I can solve for the feasible for the optimal solution. Let's say, for instance, our objective function is maximization of 10x plus 13y. So that's our z objective function. So the z value, objective function value at point A, objective function value at point B, at point C, at point D, and objective function at point E, can be computed. And this one right here was constraint 4. So 10 times x plus 13 times y. Now at point A we have 0, 0. So we know that's going to be 0. At point B and at point C and at point D we have to solve for those for exact coordinates for those points. But for constraint E we already know that's 10 times 5 plus 13 times 0, so that would be 50. And for points B, C, and D, we need to find for exact coordinates by solving systems of equations. Now, we're going to talk about that in class, or I might make another video for you for that topic. But for now, let's just say that once you find the solution to objective function at point B, at point C, and at point D, then you can compare these final values, and we've already computed two of them, 0 and 50. Whichever one is the biggest, the largest, that point will be the optimal solution. This is because we are maximizing. If we were minimizing, then of course among these values right here, we would have to pick the lowest value, and then the corner point associated with that would be the optimal solution. So depending on whether you're maximizing or minimizing, your optimal solution will change. Thank you.